Okay, today we're going to start talking about some basic derivative rules. This is also known as the best day ever because you can, unless you're told in a problem to use the limit definition of a derivative, we can just use the shortcuts or the derivative rules instead. So it's pretty exciting. It is a bigger deal in AB because they spend a lot longer having to go through that limit definition of a derivative, whereas you guys spent like maybe a week or I guess two. So anyway, so this is a good day. We can start using some of these shortcuts that I've been referring to anyway. All right, so keep in mind the reason these shortcuts work is because of the algebra that we do using that limit definition. So that's kind of the proof of why these work. And then also remember, you're still just finding a formula for the slope. Derivative is slope at any point x on each function of a tangent line. So the constant rule, the derivative of any constant function, since the slope of a constant function is 0, the derivative of a constant is 0, provided that that number is in the real number system. The power rule, again, I've referred to this in a way to check your work. The derivative of a variable raised to a power is to bring down the power out in front. The n gets multiplied out in front, and then it's x to the n minus 1 power. So I don't need to rewrite this first function. It's already in exponential form. But to use the derivative, or to find the derivative, it would be f prime of x equals bring down the 3, and now it's x to the 3 minus 1, which is x squared. That's it, the derivative of 3x squared. Remember, this is a formula to find the slope of a tangent line at any value of x. So if I said find f prime of 2, now you could plug in 2 and get 12. You might want to rewrite this next function, g of x as a cube root of x could also be written as x to the 1/3. Some people are visual and you kind of have to see that. I'm one of those people. I like to rewrite it so I could say, okay, I'm going to, for g prime of x, going to bring the 1/3 out in front. 1/3 minus 1 is negative 2/3. And we want to rewrite this so that we don't have any negative exponents. So that's the same as 1 over the 3's in the denominator already. X to the 2/3 joins it. There's a little saying that it's not the calculus that's hard, it's the algebra. It's all these little algebra details that are places where people tend to mess up, including myself. So you just have to be careful. 1 over x squared, it might be helpful to write that as x to the negative 2. So when we say rewrite, we like to have it as x to a power where x is in the numerator and it's not in the denominator. So y prime of x. Or how about this? Instead of y prime, why don't we, just so we don't forget about notation, we could also do dy dx. dy dx is equal to negative 2x. Negative 2 minus 1 is negative 3. So this would equal negative 2 over x to the 3rd. So get used to rewriting things because usually it's not just find the derivative, it's find the derivative and plug a number into it. We need to be able to do that correctly. The constant multiple rule. So if you have some constant value being multiplied by your f of x, you can find the derivative of f of x first and then multiply that constant in at the end. So you can think of this as, this is 2 over x. You can think of this as 2x to the negative 1. And you're not taking the derivative of 2 and the derivative of x to the negative 1. You're just saying the 2 is along for the ride. H prime of x is 2 times negative 1, so negative 2. X to the negative 1 minus 1, negative 2. Rewrite that, negative 2 over x squared. Basically, this is just saying, hey, if there's a coefficient out in front, that doesn't change anything. It just gets when you pull your power out in front, that constant coefficient out in front is going to get multiplied as well. I don't have anything to rewrite for this next one, but it is 4/5 times t squared. So f prime of t is going to be 4/5 times 2t, which is 8t over 5, or 8/5 t ever. I'm going to rewrite my next function, 3x to the 1/2. Let's write dy dx. Could you say y prime of x? Sure. Or just y prime, that would be fine too. 3 times 1/2 will be 3/2. X to the 1/2 minus 1 is negative 1/2. So that's 3 over 2 square root of x, or x to the 1/2 down there. Sorry, things are getting kind of jumbled here, my work. Okay, I'm going to rewrite this y. It's 1/2 times x to the negative 2/3. So when I find, I'm going to bring this all the way over here. When I find dy dx, 1/2 times negative 2/3, those 2's cancel, so that's negative 1/3. X to the negative 2/3 minus 1 is negative 5/3. And then let's rewrite that. So it's negative 1 over 3 x to the 5/3. Should I write that as cube root of x to the 5th? It doesn't really matter. What you're going to be doing with these problems is like plugging a number in and simplifying. So it's whatever would make more sense to you. All right, let's see. G of x doesn't need to be rewritten, so it's derivative g prime of x. Oh, this is nice. This one's just linear, right? So you're technically doing negative 7/4 times 1, so negative 7/4, and then it would be x to the 0, so the x isn't there. Think about it. A linear function has the same slope no matter what, so the tangent slope should match the linear slope. And finally, now this 3 and the x are being raised to the negative 2 here. They're in the denominator already, though, so let's rewrite this. It doesn't have to look that bad. This would be the same as 6 times 3x, the quantity squared. Well, that's 6 times 9, so 54x squared. That's a lot easier, isn't it? F prime of x, 54 times 2 is 108 times x. Sum and difference rules. Take the derivative of f of x plus g of x. You can separate it out. You can take the derivative of f and add that to the derivative of g, and you can do the same thing for subtraction. All that means is when we have more than one term, because so far, I don't know if you noticed, but all these were little single term functions. If we have more than one term, you can take the derivative of each term. So there's nothing for me to rewrite in f of x. F prime of x is equal to 3x squared minus 4. Derivative of 5 is 0, so that goes away. Nothing to rewrite for g of x. G prime of x is equal to 14x. The 9 goes away. Derivative is 0. Nothing to rewrite for h of x either. So h prime of x is equal to, let's see, when we pull the 4 out in front, negative 4 divided by 2 is going to be negative 2 x to the 3rd, plus 3 times 3 is going to be 9 x squared minus 2, and that's it. Here are problems, or 2 derivatives that you need to have memorized. So let's put a note there. Memorize. So this one and this one. We need to know that the derivative of sine is cosine, and the derivative of cosine is negative sine. All right. There are proofs for that. I'm sure we could find them. We could probably figure them out if we do the limit definition, but again, I'm not going to take the time to do that. So hop on YouTube if you're interested. I don't need to rewrite the function. Dy dx is equal to, so we said the 2's along for the ride. The derivative of sine is cosine, so this is just 2 cosine x. Nothing to rewrite for f of x. Take the derivative of each term. So the derivative of x is 1. The derivative of cosine is negative sine, so minus sine x. And finally, nothing to rewrite for this g of x. So g prime of x is equal to The 1/4 is along for the ride. Derivative of sine is cosine, so it should just be cosine x over 4. Pretty simple as long as you have those memorized. So here's some practice. If you want to pause your screen and then go through and check my answers, you can. I am going to talk through them though. So working on this first problem, I'm going to find dy dx. Should be 15x squared minus 4x plus 7, and the minus 8 derivative is 0. For number 2, maybe I'll rewrite this. You have a negative exponent in the denominator. That's silly. We should just make it 2x cubed over 5. And then dy dx would be 6x squared over 5. Number 3, trying to trick you here. The derivative of pi, remember pi is a constant, 3.14 whatever. So that derivative is 0. And then it's just negative 24x squared. G prime of theta, since theta is the variable, this should match the variable here. Well, the derivative of cosine is negative sine, so this would become positive 7 sine theta. For for number 5, s of x is 4x squared times all of this. Now, we haven't talked about the product rule yet, but even if you know the product rule from last year, it would be ridiculous to do the product rule when you can easily distribute this through. Then you won't have all this simplification to do. So take a moment to simplify s of x first. It's 8x to the 5th minus 2x to the 3rd plus 4x squared. And then take the derivative of those 3 terms. So s prime of x is equal to 40x to the 4th minus 6x squared plus 8x. The derivative of sine is cosine, so dy dx should be 9 cosine x divided by 2. Trying to trick you again. E in the math world is not a variable unless it's a word problem and you're told it's a variable, but this is a constant. The derivative of e squared is equal to 0. V prime of t should be 12t minus 1. H prime of theta, remember theta is the variable, so 5 theta is like a 5x. Derivative of 5 theta is 5. Derivative of cosine is negative sine, so minus 4 sine theta, and the derivative of sine is cosine, so this is still minus cosine theta divided by 3. This is rewritten for you. I probably just forgot to erase that. Okay, so good idea to rewrite this as x to the negative 1/2. And then dy dx, 8 times negative 1/2 is negative 4. Negative 1/2 minus 1 is negative 3 over 2. And so that's negative 4 over x to the 3 over 2 power. F prime of x, excuse me. Maybe you don't have to rewrite it, or maybe you just want to rewrite this little term here. The first term is the same as 2x to the negative 3. So this would become negative 6x to the negative 4. Derivative of negative cosine, well, derivative of cosine is negative sine. So this would be plus sine x. Derivative of sine is cosine, so plus 5 cosine x over 2. And instead of leaving that as x to the negative 4, we could write it as, negative 6 over x to the 4th. All right, so number 12. Remember, this is x to the 1/2. So 1/2 x to the 1/2 minus 1 is negative 1/2. Derivative of x is just going to be minus 1. And then I'll simplify that. 1 over 2, When it's just x to the 1/2, I like writing it as a square root. Just personal preference there. All right, couple more. Let's head up to 13 over here. Now, again, you might know the quotient rule from last year, but it would be ridiculous to use the quotient rule when your denominator is a single term. Remember, it's in our interest to separate this into single terms because a problem like number 1 was really easy to take the derivative of each term. So go ahead and divide it out. You're allowed to do that, right? Remember, the thing is like, oh, this looks like a heart. You're allowed to divide. That's good. You're not allowed to divide if it were, you're not allowed to split it up if it were the opposite like this. But here, x over x squared is x to the negative 1. And negative 5 over x squared is minus 5x to the negative 2. Then it's easy to take derivatives of each term. So f prime x is negative x to the negative 2. Pull the negative 1 out in front. Negative 1 minus 1 is negative 2. Next term is plus 10x to the negative 3. And then you simplify. Negative 1 over x squared plus 10 over x cubed. Okay, g prime of x. Oops, again, I can't, when I have a multiplication, remember, we didn't have a property that said, oh, just it's the derivative of this times this. That's not true. There's a product rule. But rather than using it, you should just multiply this together first to get x squared minus 4x minus 21. And then the derivative is easy. It's 2x minus 4. Done. Find the equation of the tangent line. So you need, to do that, you need a point and a slope. So we have an f of x, and we want to know what's the equation of the tangent line at x equals 1. So the point is 1 something. Let's start by finding that. F of 1 equals 1 minus 5, negative 4. So I have a point. Now I just need the slope. I get the slope by finding the derivative. F prime of x is equal to 3x squared minus 5. I need to find the tangent slope at x equals 1, so f prime of 1 equals 3 minus 5. So the equation for my tangent line in point slope form is y plus 4 equals negative 2, x minus 1. Given the position function, position is in feet, find the instantaneous velocity, we'll call that v of t, of the falling object at 3 seconds. Instantaneous velocity, that's just the derivative of the position function. So it's the instantaneous velocity. We're still talking about the slope of the tangent line at t equals 3. So just find the velocity, not the equation. So I just need to find s prime of t, and then I need to plug 3 into that. The derivative is negative 10t plus 1. S prime of 3 is negative 30 plus 1, so negative 29, and we always label. So S prime of 3 is also known as V of 3, and that would be negative 29 feet per second. Okay, last problem. Find the values of x where the function y equals x cubed minus 4x has horizontal tangent lines. What would I know? Why did they give me horizontal tangent lines? I know that horizontal tangent lines have slopes of 0. Okay, so if I could set my derivative equal to 0 and solve for x, I should be done. So let's find dy dx. 3x squared minus 4. I want to know, when is this slope equation equal to 0? I'm going to add 4, divide by 3, square root method. That's plus or minus 2 over square root 3. Those are the values of x for which the function has horizontal tangent lines. That's all we have to do. I know that we harped on you all these years about rationalize your denominator, simplify, simplify. It doesn't matter. Not that it doesn't matter. That was not all for nothing, but like on a free response, you're allowed to leave your answer like this. And chances are the scoring guide, the AP test, will have left their answer like this. Why do we keep having to rationalize? Because that is a thing. And also, if you're trying to choose multiple choice answers, you need to know that 2 radical 3 over 3 is an equivalent answer without having to rack your brain about, like, you know, why does my answer look different? Just because one's rationalized and one's not. So it's important to know that you can go from one to the other. All right, that's it for today. More to follow tomorrow.